Myself Prayak Patel, working as assistant professor in IT ICT department of LG Institute of Engineering and Technology. Now, in this lecture, we discuss about the Prolog programs, different program that can be performed in Prolog. Now, first program is write a program or write a Prolog program to find sum of elements of a list. So here given list are there and find the sum of the given list. So first is list underscore sum, then blank list, then 0. So simply we can say that this is an initial condition and second one is a recursive condition. So if list is empty, then sum of the list equal to 0. So first condition is list sum. If list is empty list, then sum equal to 0. Else we execute the second statement, list sum head tail total. If list sum t sum1 and total is h plus sum1. Now how this statement is executed, understand using the one example. So here for example we give the list is like this, list sum, then list equal to 1 to 8, then second argument as a total. Now in a given list 3 value 1, 2 and 8. Now how this total or this addition submission operation can be performed. So here move to the your statement list sum blank list. So here blank list is not available. So move to the next statement and next statement is list sum h tail then total. So this is match. Now in list 1, 2 and 8 what is the value of head and what is the value of tail? So head equal to first value 1 and tail equal to 2 and 8. So in second list we have a 2 argument 2 and 8. Now for that first we move or find the right side portion. So for the right side portion list sum t sum1. So tail equal to 2 and 8. So list of sum function call recursively, function call itself for the 2 argument 2 and 8. So in list we have a 2 value 2 and 8 and addition of these 2 as a sum1. Now after that and total is h plus sum1. But now when we call the list function recursively, list sum function second time, then what is the list? List equal to 2 argument 2 and 8. So second time find the head and tail from the 2 and 8. So 2 equal to head and 8 as a tail. So for that recursive call for the list sum tail means 8 sum1. Now we have a one value as a 8 as a head. So recursive call for the that list and list sum 8 then tail as a blank list because only one argument are there, only 8. So 8 as a head and tail part as a blank part. So call the list as a list sum tail. Tail means blank list then sum1. So blank list means call this first statement list sum blank list then 0. So sum value equal to 0 initially. Then total equal to total is h plus sum1. So sum1 equal to 0. Then head means 8. So add the 8. Then after second recursive call then find the value as a 8 plus 2 equal to 10. Then third time call the recursive for the total, then value total equal to head plus sum1. So sum1 equal to already 10 and head equal to 1 for that first requirement. So for the first iteration we find the value head equal to 1. So total equal to 11. So represent the final answer total equal to 11. So this is a simple program for total of the given list. Now understand the second program. Second program is write a program to count vowels in a list of character. So we have a one list of character, then find the number of vowels in a given list. So first this is a program, then how we can find this solution using one example. Now first vowel X, member X, A, E, I, O, U. So here list is all the vowels. If X is a member of vowels, then we can plus the vowels count. So basically this is a logic. So first find the value of X, then X compare with the list. So if X is a member of the list, then add the vowels count. Next one is a number vowel. If list is empty list, then 0. Means this is the initial condition. Now third line. Number vowel X tail and if vowel X and number vowel tail N1 and N is N1 plus 1. And last statement, number vowel xt and if number vowels equal to tn. Now understand using the example. For example, we give the one sequence, one list as a number vowels in bracket PRAYAG as a list and next argument as a n. Now our goal is find the value of n. N means total number of vowels. So here find the how we can find this vowel. So first we call the number vowels function. So initial condition statement is not satisfied because we have a number of element in a list, not as a blank list. So third statement, number vowel xtn. So here x means your head part as a p, then tail part as a rayag. So here x equal to p. Now check vowel x. So function call as a vowel x means vowel p. So call the first statement vowel p means member p AEIOU. So p is a not member of AEIOU. So we can simply say that not perform this operation. Now check for the next statement. For that recall as a number vowel tn1. So t as a tail part. So RAYG as a tail part. So recursive call for the tail part RAYG. For that first we find the value of R. So R equal to R consider as a X and AYAG as a T. So vowel R function call. So R check here member RAIOU. So this is not satisfied. Then move to the next. The next value as a. Check the vowel A as a member of X. So X as a member of AEIOU means A is a member of AEIOU. So yes, then satisfy the N is a N1 plus 1. So N1 value initially 0. Then add the value of N1 equal to plus 1. So N1 value equal to 1. So N equal to 1. Initially N1 equal to 0. So 0 plus 1 equal to 1. Same way we can perform the operation for each and every character. Then after display the result as a value of n. So here in this list we find or represent the value of n equal to 2 because total number of vowels available in this list as a 2. Now third program, write a prolog program to find the factorial of a given number. So first function is factorial 0x if x equal to 1 means if the value of x equal to 1 then factorial of the 1 equal to 0 equal to 1. So here factorial n x n greater than 0 q is n minus 1 factorial q x x is n multiply xx. Now here if you want to find the factorial of the given number n, then how operation can be performed? So first line is for the initial condition and second line is for the remaining all part. So here for example we want to find the factorial of 4 and the result is considered as a x. So factorial of 0 equal to 1 as an initial condition, factorial of 1, then factorial of 2 like this. So if you want to find the factorial of 4 then factorial for x. So here we perform the second line factorial nx. So n equal to 4 x we want to find. So 4 greater than 0 condition is satisfied, yes, then q is n minus 1. Now what is the value of q? Q means 3 because we consider the n minus 1, 4 minus 1 equal to 3. So q equal to 3. So recursive call for the factorial as a factorial qxx means factorial 3xx. So xx means result of the factorial of 3. Then after whenever we find the factorial of the 3 as a xx value, then finally we find the factorial of the n. So x equal to n multiply xx because xx as a factorial of 3 and n as a 4. So 4 multiply factorial of 3. For the factorial of 3 same recursive process 3 multiply factorial of 2. like this. So we can perform the operation like this, and finally we find the factorial of the 4 equal to 24. So this is your result. Now next program is write a prolog program to append list 2 to list 1 and bind the result to list 3. So here first append command is for initial condition. Append if list is blank list, then second list is L, then resultant list as a L. Now second append command, we already know the append command. So append XL1, second part is L2, then resultant part is a XL3. If append L1, L2, L3. So L1 append with L3, then result is L3. If we append L1 and L2, then result is L3. Then XL1, L2, result is XL3. Now for the understanding purpose, we consider the example as a append 1, 2, 3 as a first list, 4, 5 as a second list, and X as a resultant list. So here perform the operation as a append function and combine these two lists. So append function combine the list 1 and list 2 and find the resultant list as a list X. So here X equal to 1, 2, 3, 4, 5, because append used for combining the list 1 with the list 2. First list is list 1 and second list is list 2. Now next program is write a prolog program to solve the Tower of Hanoi problem. We already know what is the Tower of Hanoi problem. Now how we can solve the Tower of Hanoi problem? So first move 1xy, then blank space. So if total number of disk equal to 1, so this is the initial condition. So if the total number of disk equal to 1, then we can directly move the disk 1 from x to y. No need to any third location. So for that, first is move disk from right x, right 2, then right y. Means move disk from x to y, and new line command used for the next line. Now this is the initial condition. Now for the remaining portion, we execute this second condition. Move n x y z. So here n means number of disk. If n greater than 1 and m is n minus 1, and move m x z y and move 1 x y, then next statement is like this. Now understand one by one. Now for example, if you want to execute the disk or move the 3 disk, then n equal to 3. So n greater than 1 is satisfied? Yes. Then m is n minus 1. Means what is the meaning of m? M means n minus 1 disk. So total disk is 3. Then m equal to 2, because n minus 1. 3 minus 1 equal to 2. So if you want to move the disk from x to y using z, meaning of this statement is like this. If you want to move the disk x to y using z, then first we check n greater than 1 and m is n minus 1, means m equal to 2. Then move m x z y, means move m disk, 2 disk from x to z using y, and move 1 disk from x to y, because we have a 3 disk at the x and we want to transfer 3 disk from x to y. Then first we move the 2 disk from x to z using y, then move the last disk from x to y. Here next is move m z to y using x. Here this is the last statement. After transferring the nth disk from x to y, we want to move the remaining 2 disks from z to y using x. So this is a last statement. Now understand using the one example. For example, move 3 x y z. So here we want to transfer the 3 disks from x to y using z. So here first operation is move disk from x to y, then move disk from x to z, then move disk from y to z, then move disk from x to y, then move disk from z to x, then move disk from z to y, and last one is a move disk from x to y. So this is a simple sequence for performing the Tower of Hanoi problem for the 3 disks. Here we can use the any number of disks for performing the operation in Prolog using this program. So in this lecture we discuss the different programs which can be performed in Prolog. Thank you for watching this video.